glad to be here, I guess. Stan Bolts, I'm a regional soil health specialist. I am in the Dakotas. I also am covering Minnesota, Wisconsin, Michigan, Ohio, Indiana. I think I caught them all. Anyway, so jump right into this. Let's see if I can do this right. Grazing, cropland, and grassland. Just go right into it. What we're going to try to cover today is we're going to describe some of the advantages and challenges of grazing cropland and permanent grassland. We're going to describe some of the impacts to the cropland and also to the animals, when you're grazing on them, animal performance and soil function. We're going to briefly look at the principles of adaptive grazing management. And we're also going to just briefly again look at some management strategies for grazing cropland and grassland. So on the next couple slides, if you see an asterisk after the bullet, that means that there's a citation to a research article for those bullets. Some of them don't have an asterisk there, but they are cited elsewhere in the PowerPoint. So if you download the PowerPoint, that's in the slide notes. Anyway, so livestock manure is definitely a source of nutrients for crop production, cycling those nutrients from the crops through the animals and back to the land. Also, we're going to talk about this more a little later, but livestock on cropland causes biological acceleration. It improves soil health at a faster rate. So it adds biology, and it's also a way of incorporating that organic matter into the soil at a faster rate. It's also obviously an additional source of income.
We try to get a cover crop on almost every small grain acre, like our wheat, spring wheat, oats, rye ground. All those will get cover crops. It's been shown that the more species, the more diversity, the better they do. But the big thing, besides breaking up compaction and grabbing nutrients down low and bringing them up to the surface and holding on to them for next year's crop, is to feed the cows. We'd just as soon the cows be out grazing in the wintertime and feeding themselves than us taking them bales of hay. Less tractor hours, less man hours. Hay is, well, it's going for over $200 a ton right now. We easily paid for the cover crop seeding and the plant, and the seed itself and the planting. There's no doubt. And my husband, everything we do with the cows needs to be able to pay for itself, and he's a believer in it. Yeah, they distribute their own manure. We don't have to go haul manure out to the fields.
And we see an increased nutrient cycling and seed-to-N ratio impacts. There's studies that show increased mycorrhizal fungi abundance with livestock on cropland and more rapid building of soil aggregates. We also see improved infiltration, and I've definitely seen that comparing farmland that is just maybe no-till and cover crops, but you add livestock and you'll see an increase in infiltration many times. Salinity remediation, areas where you have saline areas, or even just areas where it's marginal cropland that really probably shouldn't be cropped. If you just go ahead and bite the bullet and plant those areas to perennial vegetation, then if you have cover crops in your cropland, you can utilize those areas better, because areas that are high in saline or that are otherwise marginal, usually if you pencil it out, it's usually you actually save money by simply not farming them. But if you can put them into perennial vegetation, then what happens is cattle many times when they go on to cover crops, because that quality is so high and where they came from, many times the quality is quite a bit different or lower, they will actually go backwards in performance for a little while because of that super high quality cover crop. So by having that perennial vegetation out there, the cattle can actually balance their diet on their own. Also, it minimizes the import of feedstuffs to the farm. If you have additional forage out there in the form of cover crops or even just residual crop after harvest, that's going to reduce the amount of feed that you have to bring to the farm, and that's one of the highest costs with the livestock operation. Also potential increase in diversity of insects, which can increase the beneficial insects and reduce pest species. Livestock also serve as a sink for agricultural byproducts. So if you think about an area where livestock have been removed from the equation for many years, and if you start bringing livestock back in, that's going to increase the local economies and bring more products back into the local economy and really just bolster that economy. So also when you bring livestock back into an area, more often than not, they're going to establish perennial forages in that area, which then actually increases the diversity of the landscape in that area too. But obviously there's some challenges to grazing cropland. And so just think for a minute, and what do you not see in that picture there? Give you a second to think about that. There's something missing, right? It's fence. You don't see a fence in that picture. And I often tell the story. I left South Dakota one time to go to a meeting over in the Twin Cities in Minnesota. And after I hit the border of South Dakota and Minnesota, I literally drove for 2 hours without seeing a fence along the road. And so Minnesota has been at this for longer than South Dakota. So in many cases, they've removed the fence. And so bringing livestock back in can be a challenge in those areas. But there's also, as time goes on, there's a lack of knowledge and familiarity about livestock management, herd health, or how to get the equipment or infrastructure that's needed or how to use it. There is an increased time and level of management to prepare the operation, move fence, all that kind of thing. And then simply just a lack of that infrastructure. There's no fence, and we just kind of mentioned that already. No water, and you have to develop that. There's a potential hassle of working out lease agreements with livestock owners, and even just finding livestock owners. In South Dakota and now I think California, and there's a brand new one in the Midwest that covers a bunch of the states that I mentioned previously, but it's called the Grazing Exchange. And what that does is it's basically a website, and South Dakota Soil Health Coalition has kind of started this, but it's a website where people that have livestock can go on there and they just put a pin on the map with their phone number basically, and they say, hey, I have livestock. And then people that have forage do the same thing, and then they can hook up, and it's easier to find people with livestock that way. It's a really handy tool. And there's a Midwest Grazing Exchange, and maybe one coming to your neighborhood in the near future. So there's also a potential risk of livestock not being moved enough, which can sometimes cause compaction. But I think you'll see through the studies that we talk about in this presentation that that's probably not as big of a problem as you might have thought. It's all about the management though. And so if you use some pretty good common sense management, you're probably not going to deal with compaction. There's also a liability possibly if livestock cause accidents on public roads. I kind of looked up the stray livestock laws in Delaware, and obviously Delaware is not an open range state, but there are some, I'd say, pretty minimal fines if your livestock get out, and I think it's $50, and like I can't remember what the second offense was. The fines go up if it happens again within a 30-day period. But on the positive side, even though it's not an open range state like it is in the West, if livestock do get out, that livestock owner cannot be held liable for damages unless they can be proven negligent. So if your livestock accidentally get out on the road and there's an accident, it's likely that livestock owner will not be held liable for the damages to the car or whatever that happens. So, but you never know with attorneys, I suppose. But anyway, so the liability is probably not a huge issue, but it is something to think about. All right, so let's look at impacts on soil health. And so research on grazing cover crops, we used to have 4 or 5 slides with different studies, and we kind of combine them into just a couple here. So if you look at cover crops overall, research that was done in Minnesota and Iowa what they saw was increased, all of those things there, increased fertility, total organic carbon, inorganic carbon, total carbon, and total living microbial biomass. Also in Georgia, grazing cover crops did not cause substantial physical damage to the soil. And then looking at grazing crop residues, in Iowa, utilizing corn stover as an inexpensive feed source was a viable option. It posed minimal reductions to soybean yield. In Nebraska, in the fall and the spring, this was a long-term study, 16 plus years. Grazing corn residue had little to no effect on soil properties and did not affect crop yields. And plus they got the benefit of all that forage for the livestock. On farm, this is a one-time study here. This is in North Dakota. So as a point in time snapshot, what they did is they looked at, basically this is Gabe Brown's ranch in North Dakota, and they compared his operation to operations across the fence. And so Gabe Brown, if you know anything about him, he does notes. He's been doing no-till for a long time, cover crops, and he has livestock on his operation. The neighbors that they sampled on basically the same soils are mostly doing conventional tillage, no cover crops, no livestock. And what they found with this snapshot was that, and you can read them all there, 7 times higher nitrogen, 4 times higher phosphorus, on down, 4 times higher organic matter. Look at the one on the bottom, 43 times higher water infiltration. And you might be kind of thinking that's just not possible. But I've done a lot of dynamic soil property study site data collection, and we have seen almost exponentially different infiltration with well-managed soil versus not so well-managed.
The more diverse the plant community and the better the management, those two things together will result in very good infiltration.
All right, so talk about grasslands a little bit. Research on grasslands in Texas, and this is compared to, what they did is they compared heavy or light continuous grazing. And when I say continuous grazing, I'm talking about continuous season-long grazing. So that's grazing for that whole growing period. Or continuous seasonal grazing would be grazing for like all of the cool season grass period or all of the warm season grass period. But at any rate, it's a long period of grazing versus multi-paddock grazing. And what we're talking about is rotational grazing. So when they compared continuous grazing to rotational grazing, what they saw with the rotational grazing was greater soil cover, lower soil penetration resistance, lower sediment loss, higher organic matter and cation exchange capacity, and increased fungal population. We talked about that on one of the earlier slides. This was in Mississippi, comparing again rotational grazing, high stock density rotational grazing to continuous grazing. What they saw with the rotational grazing was 7 times higher total soil carbon in the topsoil and subsoil, and significantly greater soil organic matter in the topsoil and subsoil. So some things to think about here, this is kind of reiterating what we talked about. What are some advantages for grazing cover crops?
Without getting too scientific, we're just trying to get that biology moving up every year, and if we can do that, then our organic matter starts to come back. We start to, you mentioned the nutrient cycle. We've been able to take, and we've done this in a test, take one side of a field, use the normal soil test, fertilize it of what it says, and then take the other half. And if we've had livestock on and cover crops and we're creating that biology, then we take the Haney test, and it shows that our biology is good enough to where we don't need fertilizer. The yield was similar. And my point is, if we're really trying to bring profitability back, and we can do some of these things without these input costs, and then the other big benefit is we're building soil health long-term for generations to come.
What are some challenges to grazing cover crops? And can they be overcome, or how can they be overcome? We talked about, just the lack of knowledge and familiarity about livestock, the lack of infrastructure, potential liability. We talked about that maybe not being as big of a deal as you think about it, and compaction. So those are some of the challenges. So we're just kind of rehashing what we just talked about. All right. So what are some advantages from grazing grasslands, whether that's pasture or range? When you look at perennial grasslands, what you're going to have, you can have high quantity, but you also have quality that spans over a greater period of time if you have a diverse perennial grassland. Think about it, a cover crop or something that just a monoculture pasture. It's going to have a pretty narrow window of palatability. With a diverse perennial grassland, you're going to expand that window of palatability over a much broader time frame. And so the quantity may be similar to like a cover crop, but the quality is going to be spread out over a much longer time frame if you have a diverse perennial grassland, whether it's pasture or range. So grazing that provides for adequate leaf area is going to protect soil from raindrop impact. It's going to reduce evaporation, increase infiltration, and improve plant vigor. And so what we want to do is maintain or improve plant diversity, and that's one of the keys when we talk about grassland. Also, some other advantages, it reduces the need for mechanical harvest. So if the more that we have the livestock out there on the land harvesting that forage for us, it's going to reduce the amount of mechanical harvest and moving feed around the farmstead.
Feed as little hay as possible, get the cows out on the land, let them feed themselves, preferably. Any opportunity you can to get the cows out on your fields where they can distribute manure and help recycle nutrients and residue is a good thing, as long as you're not out there when it's too wet and doing more damage than you are doing good.
It also leads to biological acceleration, improving soil health at a faster rate. We talked about briefly on one of the first slides, adding biology. So livestock, through their manure, through their urine, through their saliva, and even milk foam, they're constantly adding biology to the soil. And I saw a study, this was with goats, and actually what they found with goats, and in the rumen of goats, they found the exact same species of, and in this case, it was a fungal species. They found the exact same species of fungus or fungi in the goat rumen as was in the soil. So some of these critters are the same ones going between the rumen and the soil. And so think of them as an inoculant, if you will. The livestock are an inoculant for soil biology.
Feeds the soil big time. Yeah, you want dung beetles, and we're trying to get more of them out here. We quit pouring our cows dewormer and insecticides in the springtime at branding. We don't do that anymore just for that reason, because a lot of our cow pies were getting petrified. They weren't breaking down, they weren't fertilizing the pastures like they should be. It should be a natural system and a continual cycling of nutrients and feeding the soil feeds the cows, and it's all a system, right? But we were seeing cow pies laying out there for 2 or 3 years and not breaking down.
I was told that worms would be hard to get in our soil because it's abrasive and sandy a year ago, and all of a sudden we're digging up and there's worms all over the place and the soil is granulated. That's from that biology, from the cover crops, and the other big aspect of is keeping cattle on the land. We never put cattle in the drainage anymore. We used to always, these corrals behind us here, we'd always bring cattle in all winter and you fed them all winter. Where does that go? That's a creek runs through there. Where does it end up? In the Missouri River. We don't do that anymore. We keep the cattle on the land. It's a natural system. The urine and the manure is going in to support the biology. If they need a backup for feed, we take it to them. We don't bring cattle into the watershed anymore. That doesn't mean we don't graze them, but we graze them short duration and then they're gone.
And so also incorporation of organic matter. You think of vegetation that's standing up, it's going to decay at a slower rate than if it's incorporated nearer into the soil surface. That's going to increase your decomposition rates and improve that organic matter getting into the soil. Nutrient cycling also is highly bumped up, and it has impacts on the C/N ratio when you have livestock, and improved animal health. So animals, when they're out grazing, they're gonna most studies show that they're going to have better health if they're out grazing versus being in confinement. So, all right, so we're going to shift gears here and talk a little bit about some of the grazing principles. And when you look at this chart here, it's showing on the left, it's showing the percent of leaf removed, and that's on a biomass, on a weight basis. All right, so when you look at when you remove 10% of the above ground biomass of grasses, it has zero on the right, it has zero effect on the roots. There's 0% of root growth stopped. When you get to 20% removal off the top, still no effect on the roots. Go all the way down to 40%, still no effect. Look what happens at 50%. So when you remove half of the weight of the grass from above ground, it has a 2 to 4% of the roots stop growing. And they stop growing for just a few days. And when you get to 60%, look what happens. When you go just from 50% of the weight down to 60% of the weight removed, then you have half of the roots stop growing. And the other thing about that is the period of time they stop growing for is longer. So we said a few days at 50%. At 60%, that period of time goes out to a week or a little bit more. Look at 70%. When you remove 70% of the above ground forage by weight, 78% of the roots stop growing, and that period of time gets longer yet. So if you think about rotational grazing, if you're removing a lot or even continuous grazing, those roots stop growing. If they're growing, stop growing for a long period of time, they may not in that season have a chance to regrow. That has a huge impact. That's a study from 1955. Franklin Kreider was the lead author. That study that people have tried to refute that study since then, and it's held up through the time. So it's something you can kind of take to the bank with grasses. And this just shows it. This shows it pictorially or whatever. On the left, you have tall fescue, rotational grazing, and right to the right of it, just look at the three on the left there. That's tall fescue continuously grazed, continuous season-long grazing or continuous seasonal grazing. Look at the impact on the roots. So when you continuously remove that above ground biomass, it has a huge impact on the roots, as you can see here in this picture. All right, looking at this one here, when you look at the picture on the left here, or the diagram on the left, what this is showing is the typical grass roots and how they would fill up the soil. The picture in the middle here, what it's talking about here is that each and every year with perennial grasses, from 30 to 50% of the roots die off or eaten off, whatever, they disappear. Think about that, 30 to 50% of the roots disappear every year, and they have to regrow those roots. That's with perennial grasses. That most of the research actually is putting that closer to 50% in normal cases. Now look what happens if you think about what we just talked about with removing too much at the top and then those roots having to replenish themselves every year. This is what happens. The picture on the right is what happens over time, like we showed with that tall fescue. If you remove too much and that grass plant doesn't have a chance to replenish its roots, you're going to diminish those roots and provide opportunity for other plants to come in that we probably don't want. All right, so this is looking at a raise of hands. How many people have seen the rainfall simulator? I can kind of see you guys, so good. Oh, looks like most of you have. All right, so this is showing, it doesn't matter where this was done at, but this is showing 5 different pasture samples that were run on the rainfall simulator. So on the left, you have the 2 on the left, the 3 on the left, I'm sorry, are all well-managed pasture settings. So they're rotationally grazed, probably. They pay attention to how much they remove each time they graze. And so they're very well managed on the left. You have species A on the far left, species B is the second to the left and the middle one. And then the 2 on the right are overgrazed. So they're continuously overgrazed. All right, the jars in the front, as you know, if you've watched the rainfall simulator, that's the runoff jars and out here. So the water rains down on the pan, runs out the funnel, and goes out the front. That's the runoff. The water that is rained down that infiltrates through goes into the jars in the back. So look at the difference. The well managed, there's very little runoff, hardly any at all. The two pans on the right, it's a lot of runoff. The one on the far right has almost no infiltration and almost all runoff. And there's very little infiltration on this one as well. So you can see the impact. Infiltration is a very good indicator of soil health overall in a way. So it shows the impact very, very significantly here. All right, so looking at, this is a very simplified, but think about the carbon cycle. And this is without livestock, first of all. And so what happens? Plants, they respire, they give off carbon dioxide. They slowly, will fall to the ground maybe, but if they aren't trampled, they're going to just oxidize in place. But if they may fall to the ground, a little bit of that material is incorporated into the ground. It builds some soil organic matter, and that, of course, gives off carbon dioxide. But this is the carbon cycle with livestock. It's kind of like on steroids. And so the plants are consumed by the livestock. They're trampled by the livestock. The livestock produce manure. They're cycling this stuff a lot faster. And we talked about the rumen microorganisms, that there's a feedback from them back to the livestock in this carbon cycle. Respiration from the livestock. The rumen microorganisms are converting some of this to methane. There's photochemical oxidation. There's just it's a lot more robust and complex nutrient carbon cycle with livestock. And the same kind of thing can be seen with the nitrogen cycle. I'm just gonna not show that right now. All right, so let's talk about some grazing management concepts here. This is from the University of Missouri. Jim Garish, if you're familiar with that name, did this. But what it's showing here is the effect of graze period on animal performance. So on the left, you have daily intake. And if you're familiar with the nutrient requirements of livestock, especially cattle here in this case, the daily intake as a percent of their live weight is directly proportional to their rate of gain. So if they're, in this case, on the left, the first day they move into a paddock, that's what this is representing, their daily intake is 4% roughly of body weight. On day 2, after they've been in that paddock, look what happens. The daily intake drops to 3.75, somewhere in there. The third day they're in that paddock, it drops to almost 3%, over 3%. On the fourth day they're in that paddock, it's down to 2.5% or a little less. So what happens over time is you can imagine, their daily intake drops after they're in a paddock for a period of time. And what do you think is happening there? Really they're getting the best of the goodies right when they get in there, right? And so then they after they pick through the best of it, then they start going after the stuff that's maybe not so high quality. And this is a phenomenon that happens a lot in pretty much every situation. The longer they're in an area, their performance is going to start going down a little bit. On day 7 here, it bumps up. But so what's the solution? Rotate them, right? Move again to a new paddock, and then your performance, your intake will be higher again after you move them. So that's a pretty universal kind of thing. And this is kind of explaining part of why that is. If you look at the livestock forage quality in different parts of the plant. So this yellow line is 50% by weight. Now, if you look at that, it's not 50% by height, but more of the weight is in the lower half of the plant by height. More of that weight is down there. So in the top 50% by weight, look at the forage quality there. 14% crude protein, total digestible nutrients is 63.5%. Look at the lower half. Crude protein is 7.2%, and TDN is 56.3. Now 7.2 is right on the threshold of where cattle will continue to gain weight in most cases. So there's barely enough for cattle to maintain or maybe gain a tiny bit of weight with the quality in that lower half. The top half they would do fine on. So that's what's happening. It's kind of partly explains that previous slide too. All right, so I'm going to give you a chance to kind of stop and think a little bit and recap what we've talked about. So on perennial cool season grasses, what percentage of leaf area can be removed without significantly, the key word here is significantly, affecting root growth? Is it 10%, 30%, 40%, or 50%? I'll give you a second to think about that. I'll get a drink. All right. In most cases, a few people will answer 40 because that's still 0 at 40, right? But at 50%, what we said is it's just 2 to 4%. So you can go all the way up to 50% without significantly affecting root growth. That's the key there. And thinking back to that slide that we had with the table, 10, 20, 30, and the effect on the roots. What concept did we in the NRCS and in the grazing discipline? What concept did we develop from that study and that concept? What's the quote that everybody kind of remembers? And some people say is antiquated, but it still applies in most cases. It's take half, leave half, right? Take half, leave half is the principle that we kind of get from that, and still very much true. So, all right. So grazing system objectives. Keep in mind, grazing is a tool. All right. Cattle are a tool. The grass, that forage, is our crop. And the cattle are just a harvesting machine in a way, or the livestock, whatever livestock you have out there. So grazing is a tool. It can improve the resource or it can degrade the resource. It depends on how you manage them. And there's a great publication called Grass, the Stockman's Crop, and How to Harvest More of It. And if there's no other publication you have to give to a producer that has livestock, that's the one I would recommend. It's very good publication. Grass, the Stockman's Crop.
Rangeland is this, same as cropland, really. It can be overused and abused, and soil can wash down the creeks, and major erosion and undesirable species, and just it can go backwards as well. So preferably we utilize the cows as a tool. They feed themselves and feed the soil at the same time, so that it's a regenerative process. The grass is a perennial system where it needs the cows.
So and they talk about this principle that the livestock are just a tool, they're like a harvesting machine. So when you think about what are some objectives we need to have in mind when we're writing up a grazing system, the number one is to provide adequate nutrition. So we got to have that feed and forage animal balance. That's the first step, is to make sure that there's a balance there. The next thing, though, to keep in mind is you're not just balancing the livestock, the feed and forage for the livestock above ground, but there's a below ground herd too. There's a whole ecosystem of critters that live underground, and their numbers and their weight actually exceed that of all the living things above ground. So we have to take care of that herd below ground too. And that's kind of that herd below ground is an idea from John Sticka in that I think it's Soil Owner's Manual, something like that. Anyway, but with all that in mind, we still have to work within the manager's labor and social constraints, because we may come up with the best well-designed grazing system and they're moving every 3 hours or whatever the case is. And that guy says, hey, I can only move the cattle once a week, or whatever the case is. So you gotta think about all those things. What's the best system for the land, but what also works with what that landowner can do. But with all that, livestock is a fast track to soil health. Keep that in mind. What we want to do is try to mimic nature as closely as possible. So when you think of disturbances, and livestock is a type of disturbance on the landscape, but what we want to do is look at how we disturb it. So there are kind of two main types of disturbances we're going to talk about. The first one is acute, and these are just some examples of acute disturbances. They're not all necessarily directly associated with grass and grazing, but they're an example of acute disturbances. Tornadoes, hurricanes, earthquakes, volcanoes, lightning strikes, wildfires, insects, big one, and maybe large herds of herbivores on migration. That's some things in the past and in the present that were disturbances. These are acute disturbances. What are some aspects of acute disturbances, or disturbances in general? What are some dimensions of that? So we're looking at timing, frequency, and intensity. So when we look at acute disturbances, what we want to do, these natural disturbance patterns, they usually have variable timing, low frequency, and high intensity. That's kind of what we want to try to match in many cases if we want to kind of treat things like nature did, if you will. All right, so the characteristics of acute disturbance related to grazing, we want to mimic those natural disturbance patterns under changing environmental conditions as variable timing. So you think about not just the pasture as a whole, but individual plants. You know, we want to graze those at different times of the year each year. That'll help us with diversity out on the landscape, and that's one of the keys on a grassland. Plants need to be grazed just a few times per year for total plant recovery. So if a plant grows up, gets grazed, and then the cattle come back in another 3 or 4 days and graze it again, it's not had enough time for recovery. So the fewer number of times that plants get regrazed in that year, the more time for recovery they'll have. So frequency is low, timing is variable, and intensity is typically what we would call high. So most plants are grazed light to moderate to enhance that root biomass, but a high degree of trampling to protect soil surface, feed soil life, and shorten that grazing duration to prevent that regrazing. You think about some of these high intensity systems are not always the most efficient. So there is quite a bit of trampling going on. That's not a bad thing because we're getting that plant material down to the soil surface. Now, on the flip side, we talked about acute disturbances. The flip side is chronic disturbances. And that's also known as, in the grazing world, continuous season-long grazing or continuous seasonal grazing. Oftentimes, not always, but oftentimes chronic or continuous season-long grazing or continuous seasonal grazing is going to result in poor soil health.
We built some resilience in because of our intensive planned rotational grazing. So we've got grass. We'll get through this year with grass. You know, I know guys now, and it's because they're in season-long grazing. They've been out of grass for 2 months already, or 3. They didn't have grass when we had good years. Season-long means you take them out in May or whenever you take them out, and you leave them there. You never touch them until October or November. They select. So you've got constant overgrazing and undergrazing, and over time your species will narrow, your bare ground will open up, you won't infiltrate the water as well.
And so some of the characteristics of it, though, plants are grazed at the same time of year every year. You know, the cattle are moved in at the same time, they're taken off at the same time, and they're there for a long period. Frequency is high. The same plants are grazed every 7 to 9 days, however fast they can regrow. Intensity is typically low, so there's not a lot of livestock out there, but they're searching for the best parts of the plant continuously, and they're out there usually in not so high in numbers, but the grazing periods are long. There is one distinct advantage, though, to continuous season-long grazing, and that's it requires little to no management skills. So there's more management involved with the higher intensity kind of grazing systems, but higher benefits too. So this one doesn't require a lot of management, and that is one positive of it. So you think about what this looks like on the landscape. You have your cattle or your livestock that are, when you have them in this large paddock or this paddock, whatever size it is, they're concentrating their grazing over here close to the water. So these manure piles that are represented by the kind of brown, I guess, color, and the X's are urine spots, so manure and urine. All those nutrients are concentrated down over by the water. You don't get much out here away from the water. Also, you think about the grazing, the grazing impact. Very lightly grazed out here, very heavily grazed over here. Now, that's a typical pattern you see with the continuous grazing. But here's another pattern that I actually see probably more often in the Dakotas. That's what we call patch grazing, just another form of this kind of continuous grazing. What you see here is areas that are heavily grazed, and just a few feet away, you have grasslands that aren't touched. This is called patch grazing, and that's another thing that you'll see a lot of times with continuous grazing is that there's plants they're not touching, but there's also plants right close by that are getting hit heavily every few weeks or every week. You know, that's just a pattern that you'll see out there. All right, so let's look at adaptive grazing management, and just some things that maybe it is and things that it's not. So the key to adaptive management, whether it's grazing management or whatever, is that adaptive management uses feedback from the system to adapt the management to fit that system. And so in the case of grazing, it uses feedback from the grazing management to adapt that management to fit that ecosystem. Another characteristic of adaptive management, it's flexible. It has to be, because you're adapting as you go and making changes along the way. So there has to be flexibility built in. And when you think about how to build the fences, you know, is a polywire, kind of a temporary fence, going to be better adapted to adaptive grazing management versus a permanent fence? You know, that's kind of the kinds of things you need to think about. Adaptive grazing management is not a specific grazing system. So it's not this mob grazing or high intensity, low frequency. That's not what we're talking about. Adaptive grazing management can be done with continuous season-long grazing. And I've seen in a few cases where it was technically a continuous season-long grazing, but they had really good management because they paid attention and they were out there with the livestock and checking things out. And there's a benefit of this hands-on kind of management. So livestock, because the manager is out there on a very frequent basis or pretty frequent basis, the livestock are comfortable with the humans, and that's been shown with research to end up with better herd health. And there's this power of observance, just being out there. And I often say in relation to our jobs, even if you go to the field on a day like we have here today, it's rainy and cold. Even if you're out there and it's kind of a miserable day and you didn't get much done, just being out there to observe stuff is a benefit. It's a positive. So like they say, a bad day in the field is better than a good day in the office, right? So I think I said that right. Anyway, that power of observance, just being out there and seeing things, it's a positive thing. It's really powerful. And then being out there and observing things is going to minimize risk associated with unforeseen changes. You can see things as they start to happen. You can get on top of it and make changes and adjust as you go. And there's this feedback loop. This is kind of a pretty abbreviated thing, but you start off with planning, and I think it's kind of funny you assume that you're wrong. Then you implement it, you monitor as you go, you put in controls to adjust as you go, then you come back and you replan and you start the whole thing over. It's much like our 9 steps of planning. There's that loop there too, where you monitor and you assess things, and then you come back and you start over again after a while. All right, so let's look at the effective recovery period. And so what we have here is, on the left, we have continuous grazing. Then we have typical rotational grazing, 4-paddock system, and then we have a high-intensity, low-frequency grazing with a 20-paddock system. As you go across here, what you see, well, first of all, this thing that looks like a clock. Look what happens between continuous grazing and typical rotational grazing. So this is just a 4-paddock system, but you go from 100% of the time grazing, 0% rest, to 25% grazing and 75% rest. The guy that came before me here in South Dakota when I was the state range management specialist, he oftentimes said, you know, that first fence, that first cross fence is the biggest bang for your buck. If you can just talk that guy into putting 1 fence out there and splitting that pasture into 2, you're going to have the biggest bang for your buck. And you think about, this is where this comes into play. You go from 100% of the time grazing to 50% of the time grazing and 50% rest. And many times he said those guys will start to see the benefits of that 1 fence And then they'll start adding more fence on their own because they see how beneficial it was. So keep that in mind. A lot of times it's good to start small and work your way into it.
Start small, see what works, get connected with some mentors. You know, I'm president of North Dakota Grazing Lands Coalition. We have a group of mentors. I'm one. Get with those people. They've done this stuff. Somebody's got to help you. I've watched too many places. NRCS comes in through EQIP or whatever, puts in funding, and they put in water, they put in fencing. The guy's going to start a grazing system. He didn't get the backup, and in 2 years, it's back to season-long grazing. We spent all those federal dollars, and he's not made anything because he couldn't take the peer pressure of doing something different. And so you've got to start small. We started by taking one big pasture and divided it twice. And I just rotated, you know, maybe a month in one to the next to the next. And then I just observed, and I like, wow, this seems to be helping. And then we divided. We've got 100 and some pastures on this place now. And we're rotating every 1 to 7 days, depending on the size of the pasture, what we're trying to do, and all that.
And then on the far right, again, 5% of the time grazing, 95% of the time resting in this high intensity, low frequency. As you go across here, what you're seeing also is increasing livestock density per acre. Now, whenever anybody talks to you about livestock density, that's just a point in time, how many livestock out there per acre, or how many pounds of livestock per acre or per hectare, or whatever. It's a amount per unit area. It's independent of time. So if somebody's talking to you about livestock density, it's just amount per unit area. So as you go across these systems, you're going to have increased livestock density. That's what we talked about with that higher intensity under these more complex systems. Now look at the impact on, here's rainfall. You see it's ponding at the surface. There's not a lot of infiltration. With typical rotational grazing, there's less ponding, deeper infiltration. With this high intensity, low frequency grazing, no ponding, and the infiltration is going down deeper. Now this is, you say, oh, this is all just conceptual, but this was an actual study called the Pasture Project. So this is actual research information that was done. Also increasing microbial mycorrhizal activity as you go from left to right across here. This was done in, I think it was Minnesota. All right, so some grazing management strategies for soil health. How do you implement this kind of stuff? First of all, like I said, you got to provide sufficient quantity and quality of forage, so that feed and forage animal balance. You got to have that in mind. What you're trying to key in on is reducing selectivity. You want to decrease the impact on the desirable plants. The cattle or any livestock are really good at picking out not only certain species, but even the parts of that plant that are the highest quality or nutrition or whatever they're looking for, or just the tastiest, I suppose. And so we want to reduce selectivity. We want them to graze more plants, harvest more plants uniformly than just picking out the best stuff. We need to leave enough leaves for photosynthesis and cover, and I'll kind of expand on that here in a second. This is very key. We want to provide adequate recovery for plant health. So we do this by planning and controlling the grazing timing, frequency, and intensity. And the last thing is just changing that season of use from year to year. So here's what I call leaves, the facts of growth. This is true for perennial grasses, and it's a very key thing to kind of keep in mind. And so think about it. Roots below ground, they uptake and send water, minerals, and micronutrients up to the leaves for all the things they need, for their health and to grow and stuff. But here's a list: water, minerals, and micronutrients primarily is what they're sending from the ground up to the plant. However, roots do not transport carbohydrates up to the leaves. So these complex non-structural carbohydrates are not transported from this massive root system up to the leaves. But it is true that leaves, like all living things, they have to respire, and they use carbohydrates to do that. So they need carbohydrates. Where are they getting them from? So here's what they found. 5 to 10% of new leaf growth, and that's either after a grazing event or in the spring when they first start growing. 5 to 10% of new leaf growth is from the residual sheath. If you look at a grass plant, there's a sheath kind of at the base that is kind of part of the first tiller. That sheath, that residual sheath, and that upper part of the plant crown is where they get those carbohydrates from for this new leaf growth. They also recently found another carbohydrate storage area for new leaf growth, and that's in the node of a grass. So if you run your fingers up and down a grass stem, there's that little bulge. That's the grass node, and there's a small carbohydrate storage spot in there as well. That's where they're getting that stuff from. It's just the upper part of the plant crown, the sheath, and the nodes for 5 to 10% of the new leaf growth. Where does the rest of it come from? 90 to 95% of new leaf growth comes from carbohydrates resulting from current photosynthesis. So that leaf has to grow pretty rapidly and start doing photosynthesis and providing its own food. The bottom line is it takes leaves to make leaves. You got to have leaf area if you're going to have recovery on a plant. All right, so look at this picture here. On the left is on my left, I guess it'd be your left too. On the left is a continuous season-long grazing. Every time we went out there, this was one of our dynamic soil property study sites. There's cattle out there all the time, every time we've been out there. On the right is rotationally grazed. The left is about 93% non-native introduced species, quietgrass, Kentucky bluegrass, things like that. On the right, it is just the opposite, about 93% native species and about 7% non-native invasive species. Much more diverse. What's the result of that? You're going to have greater growth potential and greater resilience to provide for recovery in the event of a disturbance. There's a lot more built into that soil, into that system on the right than there is on the left. Shifting gears just a little bit here. What about haying? I remember when I first started working for Soil Conservation Service, kind of dates me, but NRCS. One of the things that I heard quite a bit is, well, hayland is pretty good use of the resource because it's covered. There's a permanent cover out there. But what we're seeing is that haying is also a disturbance that can result in poor health. I say can. Doesn't have to. It depends on how it's managed. But the way that hayland is usually managed, it can reduce soil health. This is just looking at an example of that. This was the effect of haying on aggregate stability. This is in Millette County in South Dakota, one of our dynamic soil property study sites. On the left side of this blue grazing stick, which represents a fence line. On the left was a native rangeland, well managed, rotationally grazed. On the right of the fence in the same soil was hayland, had been hayland for about 50 years. And look at the aggregate stability. On the hay field, the aggregate stability at the surface was 20% stable aggregates. As you got down into the profile, it maybe came up to 40% stable aggregates. On the rotationally grazed native range, at the surface it was 80% stable aggregates and maybe dropped down to 75 as you went down into the profile. Huge difference on the soil health between those two kinds of management. Same soil here, same study site. Look at the infiltration. On the rotationally grazed rangeland, infiltration was 27 inches per hour. This is using a 6-inch ring, and we took 5 samples. And so basically what that means is what we do is we put the ring in, we pre-wet it, then we put 1 inch of water in there and time it. So it basically took 2 minutes for the water to soak in, that 1 inch of water to soak in on the rangeland. It took almost 2 hours for the water to soak in on the hayland, that 1 inch of water, which comes out to about a 1/2 inch per hour rate. So that's what you're seeing there. All right, so I'm not going to have you spend a lot of time thinking about this one, but let's recap. What are 3 major characteristics of adaptive grazing management? First of all, it uses feedback to adapt management to fit the ecosystem. It's flexible. It kind of has to be. and emphasizes hands-on management. All right, so let's look at quickly here. This is kind of the typical kind of rotational grazing system that you'll see. It's oftentimes done by the calendar. You know, I'm going to be here in 6 days, and by this date, I'm going to move this paddock, and so on. So they start in paddock 1, they move to 2, to 3, to 4, on to 5, to 6, to 7, 8, on all the way through, kind of by the calendar, unless something major happens. Let's look at a different way to look at that. Here's a different way of managing it. This person goes from paddock 1 to paddock, from paddock 2 to paddock 1, to paddock 3, to paddock 5, to paddock 4, way over here to paddock 7, then back to 6, then to 8. So they're not going in any sequence or by any kind of calendar thing. How are they doing that? Here's one way to do that. This is actually an example, not exactly, but it's a real life person that uses this kind of thing. And this is another Jim Garrish kind of thing. They call it the grazing wedge. I think he's the one that kind of came up with the idea. But essentially what this guy does, he takes that pasture stick and he walks out through all of his paddocks once a week, and he gets an estimate with that pasture stick of the production for each paddock. And he goes back to the house and he plugs it into the spreadsheet, and he just plots it from highest to lowest. And this red line here represents the point at which he's not going to graze a paddock anymore. So once it gets down to the level that 13's at, he's going to stop grazing in that kind of paddock. He may stop earlier than that, but he's definitely not going to graze that one anymore. He also adds a second line in here. And this is these paddocks that have production above that line. He considers them kind of too rank. They've already gone too far. He should have grazed them before this. So he might use those as stockpile, or he may actually go in and hay them one time just for that year to build up his hay reserves. But in this case, if he's somewhere over here and over in here grazing, he's probably going to come back to paddock 3 or 5 to start his next grazing. That makes sense. So this is looking at this is a good kind of way of grazing on cropland, like cover crops, or a more intensive way of grazing pasture or grassland. But it's just one kind of system. It's called a strip grazing. So essentially, what you do is you have your cattle. You put in 2 temporary or like polywire type fence strands across. The sides have the electricity to hook into. Then you have your water here, which is also probably portable. You put the cattle in, and then the next day, basically, you take out that first polywire and move it out ahead and let the cattle come up here. Now they're still grazing back to that water, which is fine. And then and they're grazing, but they'll focus on this new strip of grass or cover crop that you've opened up. You keep doing that till about day 4 to 7. Most of the information I've seen says don't do this, don't back graze to the water for more than a week. Keep it to a week or less. When you get to that time frame, then you move the water up, put a back fence in, and then you start the whole process over again. This kind of strip grazing is good on cover crops. I would not really recommend it for wintertime rotational grazing, although I would recommend rotating in the wintertime as well. But you can probably get by with a much more simplified rotation in the wintertime, but it's a good idea to do that as well. Bale grazing is another good one. Bale grazing has been shown, and there's some really neat new work that's going on for bale grazing more in the eastern part of the United States, where it's oftentimes wetter. And they've worked out some systems to manage in those kind of environments, and it's been working pretty good here in the plains for quite a while now. But essentially, what it is it's kind of one of the ways to overcome that issue with hayland. So if you harvest the hay on that land, then basically just leave the bales out there, put the bales back on that hayland, and then graze it with bale grazing right on the same land. It can also be used though. If you have pasture or range that's kind of degraded for whatever reason, you can also use bale grazing to kind of treat those areas. I knew a guy in North Dakota, he bought some neighboring property that had been cropland for 50 plus years. And that soil was so, I mean, basically the whole A horizon was gone. There was no dark soil left. And he thought, well, I'm going to reseed it to grass and just start put it right into my rotation. He seeded it one year and nothing came up. And he's scratching his head. Well, there wasn't anything there for him to live on, those seeds to grow on. So what he started doing is he started bale grazing out there and then seeding those areas. And he started getting some growth finally. He had to kind of start replenishing that organic matter before anything would happen. Here's some tools you can use to do some of this kind of grazing management, not endorsing anything in particular, but here's a ATV kind of attachment someone built to put the rolls of wire on and that kind of thing. Polywire is a good thing to use in this kind of management. This is an automatic gate opener. So if you work in town and you want to move the cattle halfway through the day, or if you're gone on vacation for a couple of days and you want to move the livestock, this will open the gate automatically. It just falls and puts out a signal, and the livestock just move right in. Portable water is also a good deal. In most of the cases where we have these kind of systems, we have above ground pipeline that's shown here. It's black PE pipe, very durable. You can drive over it. Livestock can walk on it. It won't hurt it most of the time. And there's these quick couplers where you can pull up the portable tank of some kind and just hook right into that connection, and instantly you have water at that spot. Pretty handy stuff. I will say, probably maybe not quite as big a deal where you're at, but if you're going to use above ground pipeline, I highly recommend it. But put it along a fence row, and that way the grass will grow over it and it'll kind of shade it and won't get so hot sitting there in the pipe. How does continuous haying affect soil health? We talked about that. There's a reduction in aggregate stability and a reduction in soil carbon and some other probably negative effects. Some things about cover crop selection. Basically, keep in mind that warm season mixes and cover crops are going to be lower in quality. It says lower in protein here, but lower overall in quality, but they're going to be quite a bit higher yielding. Cool season mixes are going to be higher in quality, but lower yielding. So keep that in mind when you're thinking about a mix for livestock. Also, you want to limit, they say canola, I've seen where you want to limit it to no more than 20%. But in general, probably, keep the brassicas, the forb type species to no more than 50%. It says 70% here, but I'm going to say, probably 50%. You want to, in most cases with livestock, have it be a grass dominated or co-dominated kind of mix. Now, if you're thinking about sheep, you can probably shift that a little bit, because sheep are much more, they like forby kind of plants a lot more than grass plants. They'll do both, but if you're talking about sheep, you might want to shift it to more of a forb dominated kind of mix. There are some, I'm not going to go over this really at all, but there are some herbicide restrictions with livestock grazing, and you need to read the label. Really do. It's pretty significant. So do read the label and make sure that you're avoiding those restrictions and you're not causing yourself a problem with that. There are some considerations with grazing cover crops that you can get bloat. It's not probably really bloat. In many cases, it's probably too much nitrogen or whatever the case is, but you can get some problems. And here's some things to avoid those problems. Number one, don't introduce hungry animals into a lush cover crop field. Or introduce them slowly and restrict access over a 7 to 10 day period, whatever that is. You can also provide dry matter, some kind of low quality hay, millet hulls, or just open the gate to some dry pasture nearby, or crop stalks, whatever. When you're grazing those cover crops, have something that they can balance their own diet. And they will do that. They'll eat that kind of trashy stuff to kind of, so their gut feels better. Again, probably best thing with cattle is to kind of have 50% or more grass dominated. It says 25%, but it should probably be closer to 50. Strip graze if possible. Use bloat blocks if you need to. One last little knowledge check here. Where is the highest quality forage on a plant? Give you a second to think about that. You remember what we talked about? Is it the lower leaves, the middle leaves, the upper leaves, or is forage quality the same throughout? It's actually the upper leaves, right? or in the slide that we had, it'd be the upper half. So definitely the upper leaves are going to have the very highest quality. That's what you got to keep in mind when you're developing a grazing system or grazing management. All right, so I've been on a campaign to change the soil health principles here for grazing purposes, especially grazing grasslands. I'm just kidding, but there is some differences I look at when you think about the soil health principles. Number one, with the way it's normally worded is minimize disturbance. I like to say optimize disturbance, because these grassland systems, whether it's pasture, range, or whatever, these grass plants developed with grazing, over eons, and so they need disturbance to be healthy. And so we want to optimize disturbance, not minimize it. Also, cover. You can have too much cover on grassland systems or any kind of system, but you can really have too much cover. So we don't want to maximize cover. We want to optimize cover, and that's where grazing management comes into play. I will stick with the maximize biodiversity. I will say also that on grasslands, that is the most important principle right there, to have the highest diversity you can. That's going to provide the best soil health that you can get. And then maximize living roots. It's good to have a wide variety of plants. That's going to increase the amount of living root time out there in the soil. That's all I have. Ended right on 60 minutes, according to my PowerPoint slide here. So we were going to hold any questions to the end, but.
Stan, I did have one question. You had mentioned the strip method might not be best for grazing livestock in the winter. What is a better option? For winter grazing, I think more of a simple rotation, like a 4-paddock system or something like that. You just, leaving some residual out there is good any time of year. And you'd be surprised if nothing else, for snow catch. But again, remember what I said, that part of that carbohydrate storage for grass plants is in the sheath of the plant. So if you're mowing that all off, you're taking away one of its storage sites really for carbohydrates. So yeah, I think really kind of a pretty simple rotation like you would see in a simple grazing system, a 4-paddock system would be good in wintertime.
Stan, dragging pastures for manure distribution, is there more risk or reward for soil health?
It's a good question. There's a lot of things kind of that play into that. I think if you have an issue where your manure is kind of concentrated in some areas or concentrated but spread out in clumps, if the soil moisture is okay for equipment to be out there, I think it's not a bad idea. But you do want to kind of be a little cautious about that, because you're just adding more traffic, and more weight out there. I think what I would try to do probably at some point in time, that might be kind of a short-term remediation, but over point in time, I try to get a grazing system that just spreads that manure out there better, if I'm understanding your question right anyway. And another thing too is, and we're big on this in the Dakotas, and I'm not sure if you guys hear about this much in Delaware, but is dung beetles and other critters. If you can get those dung beetles back up to a population level, that's going to help that's going to help process that manure a lot better. So think about the kind of chemicals you're using on the cattle. Those can have an effect on dung beetles, and I'm just not sure what your insect population is, but if you can get those levels up, then you won't have to worry about spreading manure, because it's going to disappear really fast if you have a high population. So.
All right. No more questions. We appreciate it, Stan. Thank you very much.
Thank you.